Hello, we are discussing about GATE 2013. Look at the diagram shown. If Vs value is 100 with 53.13 degrees, then find the Thevenin's equivalent voltage as seen by the load resistance RL. We are going to find out Thevenin's equivalent resistance across these two terminals. Okay, as seen by the RL. So say it as A and B terminals, that is load terminals, and now we are going to check about what is the Thevenin's voltage across this A and B terminals. You are looking into load resistance. Okay, Thevenin's equivalent. Thevenin's theorem says that any complex network can be equivalently represented with a Thevenin's voltage in series with Thevenin's resistance. Thevenin's voltage is VTH and Thevenin's resistance is RTH. Okay. And if you are going with A and B terminals, that is you are going to implement this entire complex network into this A and B terminals, then the value of VTH is the answer for us. Okay. So VTH means open circuit voltage across the terminals. So which terminals you are interested in? For which terminals you are going to calculate Thevenin's resistance for that one. Okay, open circuit voltage you should calculate. What is the voltage across those two terminals? VTH means open circuit voltage across the interested terminals. Okay, and RTH is the equivalent resistance across those terminals. Okay, now we are only interested in VTH. Open circuit voltage means you must remove this RL. So first of all, first step means remove RL. Then only you can calculate the VTH. Remove RL. So I am removing this RL. If you are removing this RL, at that time it will not become a closed loop. It will not become a closed loop as you are removing this RL, because these two terminals are kept open. In open circuit, no current flows. That means I2 is equal to 0. Whenever I2 is equal to 0, voltage drop across this one is going to be 0. Voltage drop across this resistance is also 0. Because voltage drop can be calculated by using I2 into XL and I2 into RL. Something. So as I2 is equal to 0, 0 into something is 0, 0 into something is 0. So there is no voltage drop across these two elements. So now VTH is equal to, you can write it as VTH is equal to, okay, 10 times of, you are applying KVL for this one. So this is 10 times of VL1, okay, plus voltage across J6 ohms plus voltage across 5 ohms, which is nothing but VTH. But as it is 0, this is 0. So we can say VTH is equal to 10 times of VL1. This is first equation. And second equation says we need to calculate VL1. If you are able to calculate VL1, then we can get the answer of VTH. Okay. Now look at VL1. VL1 is the voltage across J4 ohms. That is, the voltage across this inductor is VL1. And how much current is flowing through this one? This is I1. Okay. So where VL1 is equal to voltage drop across J4 resistance, J4 impedance. Okay. Already inductive reactance is already given, that is J4 ohms. Okay. Which is nothing but you can think it as XL. So current flowing through it is I1 into J4. And how do you calculate I1? I1 is equal to, you can write the KVL for this one and you can obtain I1. I1 can be written as total voltage Vs minus J times of 40 I2 divided by 3 plus J4. So voltage difference divided by the entire resistance, that gives the I value. So Vs minus J40 I2 by 3 plus J4. While you are calculating Thevenin's voltage, you are making you are making output, that is terminals of interest, as open. Okay, that is by removing RL we are going to calculate Thevenin's voltage, because Thevenin's voltage is nothing but open circuit voltage. Whenever you are making it open circuit at the AB terminals, I2 is 0. I2 is 0 is nothing but this term is also 0. So simply I1 is equal to Vs divided by 3 plus J4. So use that one. VL1 can be calculated now. J4 divided by 3 plus J4 times of Vs. This is VL1. Okay. Now use 1 and 2 equations. Use 1 and 2 equations. Now you can get it as VTH is equal to 10 times of, okay, VL1 is nothing but J4 divided by 3 plus J4 times of Vs. So you can write it as J40, 10 into 4 is 40, divided by 3 plus J4. You can write it as in polar form, square root of 3 square plus 4 square, that is magnitude, which is 5, and angle is tan inverse of 4 by 3, imaginary by real. Tan inverse of 4 by 3 into Vs. This Vs is given. So now I am going to substitute that one. J40 divided by 5 times of 53.13 degrees, tan inverse of 4 by 3, and it has given as 100 times of 53.13. So VTH can be calculated. VTH is equal to, first we will write magnitudes one side and the other side phase angles. So magnitudes is J40 into 100 divided by 5. So 5 into this is 20, and phase angles now I will write. Phase angles J40. Okay, so you can remove this J. Okay, you can remove this J and you can write this phase angles. In terms of phase angle, you can write it as J40 means 40 times of plus 90 degrees. Only this is simple J, and J4 can be represented as 0 plus J4. So magnitude is square root of 0 square plus 4 square. So you will get 4 only, and tan inverse of imaginary by real. Imaginary is 4, real is 0. Something by 0 is infinite. Tan inverse infinity is 90 degrees. Okay. So if it is J40, you will get it as 40. 40 of 90 degrees. So 40 of 90 degrees. So you will write 40 here and plus 90 here. Plus 90 plus 53.13, which is related to the source. Okay. And this is 53.13 in the denominator, that will come in the numerator as minus. So this and this get cancels. You are going to get 40 into 20, 800, and this is 90 degrees. So Thevenin's voltage is 800 of 90 degrees. So the right answer for this question is C.